So we have this question here that says verify the Moivre's theorem for n equals to 2 and n equals to 3 here. So now we know that the Moivre's theorem states that if you have cos theta plus I sin theta here to the power n, this should be equal to cos n theta plus I sin n theta, like this here. So now let's check the values for n equals to 2. So for n equals to 2 here, we're simply saying cos theta plus I sin theta here to the power 2 should give us cos 2 theta plus I sin 2 theta here, like this. Okay, so we evaluate what's on the right hand, what's on the left hand side, this side here. So here we can just expand this. So we have a cos theta plus I sin theta, like this here, multiplied by cos. So we're evaluating the left hand side, this side, so that it should be equal to the right hand side here. So we have cos theta here plus I sin theta, like this here. So now here, cos theta by cos theta, we get cos squared theta here. Cos theta multiplied by I sin theta here, we get plus I sin theta cos theta, like this here. I sin theta multiplied by cos theta here, we get plus I sin theta cos theta, like this here. So I sin theta multiplied by I sin theta this side, we get plus I squared sin squared theta here. Now remember that since we have that the value of I squared is equal to negative 1, so meaning that here we're going to have cos squared theta plus this and this term here are like terms, so meaning that we can simply add them. We're going to have 2I sin theta cos theta, like this here. Then if I is equal to negative 1, then this becomes negative sin squared theta, like this. So now we add the real parts together and we leave the imaginary part, like this here. So we have cos squared theta minus I minus sin squared theta plus I 2 sin theta here and cos theta, like this here. So now remember that cos 2 theta, the identity of cos 2 theta is simply equal to cos theta cos squared theta minus I sin squared theta here. We know that cos 2 theta has 3 identities, but then we're simply just going to focus on this one here. Then for sin 2 theta, the identity is 2 sin theta cos theta, like this. So when we make substitutions here into what we have here, we're simply going to have cos 2 theta here plus I sin 2 theta here. If you look at this, this is equal to what we have on the right hand side, this side here. Okay, so therefore we've verified the Moivre's theorem for n equals to 2 here. Okay, let's also verify for n equals to 3. Okay, let's verify for n equals to 3 here. So now when n is equals to 3 here, we're simply going to have cos theta plus I sin theta to the power 3 should be equal to cos 3 theta here plus I sin 3 theta, like this here. So now here we know that the expansion of a plus b here to the power 3 is simply equal to a to the power 3 plus 3a squared b here plus 3ab squared plus b cubed here. So we're going to use this expansion that we have here for what we have on the left hand side, this side. So here we know that when you expand this here, this you say let A be equal to cos theta and B be equal to I sin theta like this here. So now if we replace this into the expression that we have on top here, you notice that here we are evaluating the left hand side so that we show that it's equal to the right hand side this side. So now here we have cos theta plus I sin theta like this to the power 3 here. This will simply be equal to cos cubed theta plus 3I cos squared theta sin theta like this plus 3 here I squared. So okay, so we have cos theta here and we have I sin theta squared like this here plus I sin theta to the power 3 like this here. Okay, so here we have cos cubed theta plus 3I cos squared theta sin theta here plus 3 cos theta I sin theta squared and I sin theta here to the power 3 here. So now let's simplify what we have here. We have cos cubed theta here, okay, plus 3I cos squared theta sin theta like this plus here you notice that here we're simply going to have a 3I squared cos theta sin squared theta like this plus this side here we're going to have I to the power 3 sin theta here sin cubed theta like that. So now since we know that A squared is simply equal to negative 1 and I to the power 3 is the same as I squared multiplied by I like this here. So the value of I squared is negative 1. If we multiply negative 1 by I here, we're simply going to get negative I like this here. So basically here, what we're simply going to have there is a cos cubed theta plus 3I cos squared theta sin theta. Then where there's I squared here, we're going to put negative 1 here. So meaning that we're going to have minus 3 cos theta here sin squared theta like this. Then this side here we've said I to the power 3 is simply negative I. So here we're going to say minus I here sin cubed theta like this here. So now here we know that sin squared theta is simply equal to 1 minus cos squared theta like this here, and cos squared theta is simply equal to 1 minus sin squared theta like this here. If you look at what we have here, if we add the real parts together and also the imaginary parts together, you notice to say that on the right hand side of this expression that we have on top here, the imaginary parts is just the sine function alone and the real part is just the cosine function alone here. So on whatever real number that we have here, we're going to change this sine function here into a cosine function by replacing with this identity this side. Then for this imaginary part here, we replace the cosine function that we have with a sine function so that it matches with what we need on the right hand side this side here. Okay, so here we have cos cubed theta minus 3 cos theta here. Then where the sine squared theta, we're going to put 1 minus cos squared theta here. So we put 1 here minus cos squared theta like this here, plus here we're now adding the imaginary parts. So now where there's cos squared theta here, we're going to put 1 minus sin squared theta. So meaning that here we have 3i sin theta, open brackets, 1 minus cos squared theta, like this here, minus I sin cubed theta, like this here. If we simplify everything that we have here, so if we simplify what we have here, we have cos cubed theta like this, minus 3 cos theta plus 3 cos cubed theta, like this here, plus this side here we have 3i sin theta minus 3i sin cubed theta minus I sin cubed theta, like this here. So now here, this cos cubed theta and 3 cos cubed theta can be added together. So meaning that they'll give us 4 cos cubed theta, like this, minus 3 cos theta here, plus this side here we're going to have 3i sin theta minus 4i sin cubed theta, like this here. Now here, let's simplify this a little bit further. So we have 4 cos cubed theta minus 3 cos theta plus, open brackets, 3 sin theta minus 4 sin cubed theta, and we have the imaginary part I this side. Now here, we know that the identity of cos 3 theta here is simply equal to 4 cos cubed theta minus 3 cos theta, like this here. And also the identity of sin 3 theta here is simply equal to 3 sin theta minus 4 sin cubed theta, like this here. So now if we substitute this here into the expression that we have on top here, we're simply going to have so let me just do this here. So if we substitute this into what we have here, we're simply going to have cos 3 theta plus I sin 3 theta, like this here. If you look at this here, this is equal to the right hand side of our expression on top here.